if you remember, we had from yesterday, 5 compounds up here. And we left off with these two, saying this one's probably the most difficult one that we would have up here. And I think we left off with, was it cis-butene? Does that sound correct? Is that the last thing you wrote down? Is that a yes? Okay. So if cis-butene is where we left off, this methyl group was up here. I shouldn't say methyl, but the CH3 is up here. That's where we left off. So this would be just the opposite. Remember on your matching, you had 2 questions like this. Okay. Okay. That's that cis compound. But if these methyl groups are pointed in opposite direction, it would look like. Now we've got that trans isomer, and that's what this would refer to as well. Notice it's not a straight chain of 2-butene, okay? And part of this is due to the restricted rotation between this double bond. Remember, one of the things, we didn't spend a whole lot of time, but it's double bonded, or excuse me, single bonded, it can rotate around 1 bond. But once you got 2 or double bond, that restricts its rotation. And that's why you could possibly see a compound like this. Okay, so whatever it is that would make sense to you to remember that this is a trans compound, whether you've got what appears to be a methyl group on each side, which to me could be confusing because then you're not saying it's part of the parent chain. The best way to look at that, I think, is look at your hydrogens. Those are pointing in opposite directions, just like these hydrogens are pointing in opposite directions. Does that make sense? Okay. So if that is the case, which it is, this is butene, but we need to be a little more specific with that. Just look at your hydrogens. They're pointing in opposite directions. Okay, so we got trans, and that double bond is after which carbon? After the second. Okay, we got 1, 2, 3, 4, or going in the opposite direction. Okay, it's also after the second one. Because what could happen is you don't necessarily have to have just 1 carbon there. We could do something like this even. That is still a trans compound, but now rather than trans 2-butene, now you would have trans to what? Hexene. Did I put 6 up there? 2, 3, 4, 5, 6. Yep. Did we lose anybody in that jump? Okay. Okay. So we did this yesterday. Okay. We just called this straight butene because it's a straight chain. There's no orientation where hydrogens are pointing in opposite directions or the parent chain is not pointing in opposite directions, it's just a straight chain. If we wanted to make an isomer of this, one of the things we said is do what with this double bond? Just move it over 1. So the difference between these two, okay, for this one is where the double bond is located. Now the difference between this one and this one is just the geometrical shape. That's why it's called a trans compound. Look, you don't have hydrogens pointing straight up and down like you do here. These are pointing in I don't know what you would call that, 115-degree angle. There's no really specific number for that. But as we all know, of course, that's going to be a right angle. But if it's looking something like that, whatever that angle is, maybe 120, 115, something like that. My point is, it's not a linear straight chain like this one is. Yes. Yes. Yep. For this one, yes. That's why we said we're going to leave this one for last, because this one's the most difficult one. Well, you count the cars in the parent chain. Nothing's changed, right?
How does it become trans if like that's part of
I mean, why are we using this terminology when all four of them were counting? That's what I'm interpreting your question. Okay. But what I'm the best way for me, and I'm explaining this and it makes sense to me, we could get the book out and then they're going to give you all different types of terminology. But to me, it's just easiest on how we actually see it. It's straight, 180 degrees, rather than what we see here where it's angling up and down. Looking at that. Now, would you rather, well, it's not fine if we don't understand.
if I'm being honest, like just if we keep explaining it, I'm just gonna kind of more.
But
Like I don't even know what I'm confused on.
well, if we were to draw cyclobutene, which is possible, you would understand the difference between cyclobutene and butene, right?
Yeah, the thing like I'm the most confused on is why you go like 2, 4 trans butane is just a full parent chain.
Okay. And there again, because we know if it's a four-sided figure, the shape is going to illustrate is going to be in the name, right? Cycle is going to mean ring structure. Okay. So if we see cis or trans, it's the restrictions on this double bond that do not allow it to be a straight chain like this. It's the restricted rotation within that double bond that makes this happen. That's what the author explains, and that's just recognizing that's the only way, that's the best way I can explain it rather than just reading it right out of the book. And we're trying to make the analogy that, again, if you see cyclobutene, you know it's a ring structure. If you see transbutene, it's not a straight chain like this. It's got a restricted rotation that causes that to bend up and down. All right. Oh, we didn't finish naming it, did we? So trans. Okay. And doesn't matter which direction you go. We got 1, 2, 3, and 4. It would be the same as going back this direction. Trans dash 2 dash butene. Okay. Again, it's the shape that that compound looks would tell you that. Okay. All right. Okay. Now, we said go by your hydrogens when you're trying to decipher if we have a cis or trans to butene. And in this case, okay, does this have hydrogens pointing in opposite directions or the same direction? No, it does not. Because remember, okay, one of the things we're going to hand out, okay, is these R compounds on these flow charts. R just means any hydrocarbon. It's a carbon. It can be CH2. It can be CH3. It's just a variable. That's all R is. Okay. So we know that if those two hydrogens are pointing up like this, it's a cis compound. We know that if one is pointing in opposite directions like that, we know that that is a trans compound. But this does not have hydrogens pointing in either direction. Okay. So with that being said, this is not a cis or trans compound because you don't have just hydrogens like that. So we need to take that one step further in recognizing the geometrical shape. Okay? That's why we spend time on this. Yes, this is hard. This is confusing. And we hope that continually going over these, we break that barrier down. Okay? So this is still the same thing we want to do. We don't see hydrogens pointing in the same or opposite direction. You still are going to want to count your parent chain, which is how many carbons do you think? It's still 4, okay? Whether you go 1, 2, 3, 4, 1, 2, 3, 4, or 1, 2, 3. I guess I did that once already. Now, so we know that 4 is our parent chain. It's a double bond. So our suffix is ene. Our prefix is 4. Okay. But once we do that, if we go 1, 2, 3, 4, or 1, 2, 3, 4, 1, 2, 3, 4, my point is we've got a methyl group branching off of one of those. So we're already nodding our head yes. To give us the lowest combination, would we start down here or start down here or up here, do you think? Do we start on that side or this side? Start on the left. This is why. Okay? One of the reasons we're saying that is if we start over here to what carbon is this going that direction? That's 3. But if we start on this side and go that direction, it's on what? Second. Okay, so we're just going to start here. On this second carbon, what do we have branching off of there? A methyl group. Okay, so we still account for that. And the last thing we need to do is we need to put 2 numbers in there. Okay, one, what's branching off the second carbon, like you correctly said. You've got a methyl group up there. And then where is that double bond after which carbon? Second one. Okay, I didn't leave enough space there, so that's why we kept that one for last. 2-methyl, 2-butene. Okay. And the author goes in and also explains you can put halogens on there as well. Okay, but we haven't quite got that far yet. Okay. Is this difficult? Yes. No one's going to argue with that. We said that many times. Okay, but it's when we keep working at it, we hope, and hopefully we can accomplish that. Okay. I was going to go a little further in the content today and start the addition reactions, but it doesn't sound like we're quite ready for that yet. Okay. But I'm going to hand these out and I won't lose them. Okay. Or do you think if you see these, it's going to be too overwhelming for you? Are you speaking for everybody? Yeah. It's a front and a back, and a front and a back. Okay. Nope. These are flow charts. And you might be looking at these. Okay. Okay. So as you look at these, you're going to say, this means nothing to me. Well, because you haven't been taught that yet. But there is one set of reactions that is on here that you might recognize. So that I did want to ask. Of all the reactions on here, can you recognize one that we have discussed? It's not on the back side of this that has all the benzene molecules. It's on the other page. Has something to do with halogens. It's on top of one of the pages. Yeah, yeah, yep. Halogenation of alkanes. That we have talked about. So there's really no reason to hand out all of these and then have you look at them, just let it be so overwhelming at that time. Because you'd be looking at this and, well, why do I have this? And there's only one set of reactions that you had to worry about. Okay? So at some point within the next probably 2 weeks, we will be using these. Okay? So like I said, it's one of those aspects. If we just keep working at it and keep working at it, okay? We do our best. This is the material. It's not anybody saying, let's try to make this just as difficult as we can. No, that's not the point. This is the material. And it's one of those that we chose to come in here and take. Just think of how bad that might be if this is something you have to take in college. You haven't even looked at it yet, ever. Okay? So hopefully we can agree that this is for your benefit. Okay? for those of you who may need this. All right, we'll stop there for today. We'll pick up with this tomorrow.